Alright, welcome to section 1.2. Here we're going to talk about some relationships between angles, and so we're going to go through some terminology that they have up front and then work some problems together that you'll find in the homework. And so as we look at this, if I start at the beginning, they're talking first about vertical angles. And there's some really good pictures in your book on page 10 that will help with this. But we'll use this as a guide. The best way to look at vertical angles is if I had two lines that cross just like this and label these guys, the vertical angles are this angle and this angle are exactly the same. And this angle and this angle, and so this is just two lines crossing. These vertical angles, the blue angles and the red angles, will be the same. We have to use that to creatively find measurements of angles in the homework. Parallel lines are lines, I want to direct your attention to over here. Parallel lines are lines M and N. They're just directly parallel to one another. A transversal is the red line that's crossing the two parallel lines M and N. And so we call that red line a transversal. And so we have some relationships that are present if you have a transversal crossing two parallel lines, which honestly happens quite a lot enough just to mention them. So the alternate interior angles are equal. So as we look at the alternate interior angles, well, what are those? Those are angles like 4 and 5. Do you see 4 and 5? These are on the interior, and they're on the alternate side of the transversal, so they're equal to one another. So 4 and 5 would be equal to one another. 3 and 6 would also be equal to one another. See that happening here? The 3 and 6 guys would also be equal to one another. Maybe I should do angle 4 is equal to angle 5. Okay, let me get rid of those marks there. Alternate exterior angles are also equal. So what are the alternate exterior angles? That's like number 1 and angle 8. They're on the exterior of the parallel lines and they're on alternate sides of the transversal. So if 1 and 8 are equal, 2 and 7 are also equal. Interior angles on the same side of the transversal are supplemental. Yet visually you can see that. You can see that angle 1 plus angle 2 adds up to be 180 degrees. And you can see that 3 and 4 also add up to be 180 degrees. So if you're on the same side of the transversal, and on the interior or even the exterior, it would add up to be 180 degrees. But specifically they're talking about, well, you can see the 1 and 2, but then they'll also claim that 4 and 6, right? Interior angles on the same side of the transversal. That's probably a better way to read that. 4 and 6 is 180 degrees, and 3 and 5 are adding up to be 180 degrees. Right? So you can see that there's a lot of supplementary angles, and corresponding angles are equal. So the corresponding angles are 2 and 6. Right? These two are equal. 4 and 8 are equal to one another. 1 and 5 are corresponding, and 3 and 7 are corresponding as well. And so we'll use all that to solve some things. An acute triangle, let's talk here. The sum of the measurements of the angles of any triangle is 180 degrees. An acute triangle has all angles less than 90 degrees. A right triangle has a 90-degree angle. An obtuse triangle has just one angle over 90 degrees. An equilateral triangle, they have all side lengths are the same. An isosceles triangle, two sides are the same. And a scalene triangle has no equal sides. You might not have ever heard that. Not used very often, but it's true, has no equal sides. So they're going to talk about triangles at some point in the homework, and corresponding triangles, similar triangles, meet the following conditions. Angles must all have the same measure, and the corresponding sides are proportional. Okay, so you're really looking that all the angles match up, and then there's a proportionality between all the sides. So as you look at example 1, what they want to do is have us, they say find the measures of angle 1, 2, 3, and 4 in the figure, given that M and N are parallel. So you have the same two parallel lines being cut by a transversal. And so we're going to use something that we know. What we see is 2 and 3. And 2 and 3 are interior angles on the same side of the transversal, and therefore they add up. They must add up to be 180 degrees. And so I put what they are algebraically. And I have a little bit of a miscopy there. So I have angles 2 and 3 being added together and set equal to 180 because they're they're the interior angles on the same side of the transversal. So now we got 16x plus 4 is equal to 180, and so we have 16x is equal to 176, and so we get x is equal to 11 pretty quickly. That 11 is going to be able to allow us to solve a lot. So first of all, we know angle 2 is 9 times 11 plus 9, or 99 plus 9 for 108 degrees. We know angle 3 then is 7 times 11, or 77, minus 5 for 72 degrees. And if we know that, then we definitely know angle 1. Let's just go numerically now. Angle 1 is it's a vertical angle, and so it's going to be the same as the angle across from it, or 108 degrees. If we look at angle 4, that is adding up to 180, or the same as number 2, and so number 4 is also going to be 108 degrees. So hopefully you followed that. So I justified the 4 being 108 degrees because it should be the same as number 2, because they're these corresponding angles that are there. The other way to see it is this is 72 degrees right here. I got to get the makeup to 180. That's 108. And so we justify number 4 being 108 degrees. And so nice little rationale there. On this last page of 1.2, we have a problem very similar to something that we did in the last section. We just have to take 11x plus 12 plus 4x plus 123 and set that equal to 180, since they're supplementary angles. So that's 15x plus, we look at 123 plus 12, we get 135 is equal to 180. And so that's 15x is equal to 180 minus 135, or 45 degrees. And so we get a nice little x is equal to 3. Okay, and so we have 3. Now we're going to drop that 3 in and take 11 times 3 for 33 plus 12 to get 45 degrees. And we're going to take 4 times 11 plus 123 to get 100 and not 4 times 11, apologize. 4 times 3 should have been what I had. Plus 123. I saw that answer, I'm like, that can't be right. For 135 degrees. I don't know where I got the 11 from, but x was 3. So A is 45 degrees, B is 135 degrees. These two triangles are known to be similar triangles, and so we can use proportions to solve for x. So what they tell us is that A is 13 B is 12, and C is 5. They tell us E is 24, D is 26, and we're looking for that X. And so we can set up any ratio that we want. So as long as I'm taking a ratio that's of one triangle to the other or sides of the same triangle, I'm doing it right. So I could do something like X is to its hypotenuse 26 as 5 is to its hypotenuse 13, and just set it up like that. I could realize that there is a times 2 relationship here and use that to my advantage to find out that X is equal to 10. Or I could do cross multiplication and say 13x is equal to 26 times 5 for 130. Divide both sides by 13 and come up with x equals 10 that way. There's no units to put on it since they didn't provide any units. We have some units here though. So a tree casts a shadow 42 meters long. So here's our tree. Okay, we'll make it look like a tree kind of. And it's casting a shadow that is 42 meters long. At the same time, a shadow cast by a 30 centimeter tall statue. So here's our statue. And that shadow is 66 centimeters long. And this is 30 centimeters. So one big problem that they're doing is they're mixing units on us. And the question that they want us to find is find the height of the tree. So what's the tree height? Now, it would be best to convert these. 66 centimeters is not even 1 meter yet. It's a centimeter is a hundredth of a meter. And so 66 divided by 100, I'm going to change these out to 0.66 of a meter. And this would be 0.3 of a meter. That might be better that they all have the exact same units. I'm at least worried about that. And then we just set it up. I'll put the height of the tree up top because that's what we're solving for. All over 42 has to be the height of the statue all over 66. Now actually it wouldn't have mattered if I converted or not because it's all ratio based, but I just wanted to do that in case somebody thought that there might be a problem. But we could solve this because having a calculator with us, doing 0.66t is equal to 0.3 times 42. And we know what to do. 0.3 times 42 divided by 0.66. And we're going to get a number. T is equal to 19 and it goes 0.9 repeating. So we're going to say the height of that tree is 19 meters tall. Right? So a meter is about a yard, so it's 19 yards tall, which is pretty big, right? So in terms of feet, which we usually talk about, it would be 57 feet tall. So that's a pretty tall tree. That's what we'd be doing in this section. You'll watch yourself do different application problems like this. So let me know which ones are causing problems. All right,